Following on from some of our earlier videos, we're trying to work out the volume of this 3D solid. But rather than summing up all these shells, we are going to sum up all these slices. So we are going to work out the volume by summing up all the slices. And the reason why we're summing up all the slices is because by working out the volume of this in slices, we can see why q squared equals v. You see, you can also work out the volume of this thing by summing up all these shells, which would be a lot easier. But then by doing it in shells, you won't be able to see why q squared equals v. But then by you summing up all the slices, you will be able to see why q squared equals v. Okay, so our aim here is to work out the volume of this. So don't forget, this here is our plan view. So when you're looking down on this 3D solid, it will look like this. So this here is the highest point, and then it gradually flattens out as you move out. Okay, just a reminder, this is our 3D solid. If you get a knife and then cut it along here, along the y-axis, so that's the same. So looking down on it, it will be you cutting along here. Don't forget, it goes all the way from infinity to negative infinity. So it's really you cutting all the way down here. Well, anyway, if you cut it, if you imagine getting a knife and cutting along the y-axis, looking down on it, it would be you cutting along here. But then when you cut along here, you get a cross-sectional area looking like this. Okay, and the formula for this graph here is e to the minus x squared. And then, as another reminder, if you get a knife and cut it along the x-axis, so that's you getting a knife and then cutting it along here. And then if you look at the cross-sectional area, it will always it will give you the height of e minus x squared. Because and the reason for that is because you're revolving it 360. Because you're revolving it, so no matter where you cut it, if you cut it diagonally across here, then this bit here will look just like this. Okay. If you cut it at an angle here, it will also give you this. But then if you cut it along here, it will give you a smaller version of this thing here. Okay, so our aim here, if we want to work out the volume of this 3D solid here, our aim here would be, well, the volume of that solid would be us summing up all the areas. So the volume, hang on, so the volume of this thing here would be us summing up all the slices here. So we're summing up all the slices. So we are moving in the x direction. We're summing up all the slices. So if you just look at this this random slice here, then that's really you summing up all the areas. So this is a of x here, a of x here. So you're moving. You're moving in the x direction. As you're moving along in the x direction, right at this point here, that will the area of this bit here is given by, well, it is this bit here. Okay, so the volume is really you summing up from negative infinity all the way to positive infinity. But remember, you're summing up all the areas. So as you're moving across here, hang on. So the volume is given by you summing up all the areas as you're moving across in the x direction. So right here is this area here. Okay, so don't forget, you're summing up everything. You're moving across in the x direction, so you're summing up everything. By the time you get to here, that's this area here. So the volume is given by us summing up all the areas as we move from negative infinity all the way to positive infinity. So we need to find a way of obtaining the area as x is moving, as we're moving across in the x direction. So hang on. So as we're moving across in the x direction, we need a way of obtaining the area. Let's say by the time it gets to b, to x equals b, which is this bit here. By the time it gets to here, then we need a way of obtaining this area here for for any given, so we are moving in the x direction. As we're moving in the x direction, we need a way of obtaining this area here. That's this bit here. So we need a way of obtaining the area as we're moving across in the x direction. I will continue in the next video.